Alrighty, so continuing on with assignment 14.4, let's look at 11 through 15. So these times though, we're not going to do probabilities of independent events, we're going to do the probability of dependent events. So when events are dependent, what we are going to assume is that the first event always happens. We have to assume that. And then the second event will happen after that. So what is the probability that a student passes geometry given they have done all of their homework? So what we know is they have done all of their homework. So how we're going to write that is we're going to say the probability they pass in this vertical line means given they do their homework. And how we're going to do that is we're going to find out that the probability that they pass and do homework divided by the probability that they just did homework. The second event always goes on bottom. The probability of the and always goes on top. So generically, we are going to write that. Oops, let me write that down generically. So generically, if we're going to say find the probability that B happens, given that A has already happened, is going to be the probability of A and B over the probability of A after the vertical bar is always assumed to have happened. All right, so that's how we're going to say that generically. So there are 8 shirts in your closet, 4 blue and 4 green. You randomly select one to wear on Monday and then a different one on Tuesday. I'm going to assume you washed Monday's shirt. You wear blue shirts both days. At random, you just picked 2 blue shirts. Now, this really isn't the probability that I showed you, but we're still going to follow our rule. I'm going to say the probability of blue, because it's an and, blue and blue. You know what, let me say that. So that is a probability that we're going to wear a blue shirt and a blue shirt. So probability that I wear blue and blue. Sorry, the writing is so bad. I don't know why my tablet's acting up. That's going to be the probability of blue multiplied by the probability of blue. Well, the probability I get, there are on Monday, when I reach into the closet, there are 4 blue shirts on Monday, and I have 8 shirts in total. On Tuesday, when I reach into the closet, there are no longer 4 blue shirts. There are 3 blue shirts, and there's no longer 8 shirts in total because one of the shirts is no longer in the closet. There are 7 shirts. So I will let you finish that up for number 11. You can hit pause, bang that into your calculator, and get that answer. Now, this is what I was telling you. This is what we call conditional probabilities. So if I tell you, let's find the probability that B happens given that A has already happened. There's my formula. All right? So that comes in when we see stuff like this. In the following problems, events A and B are dependent. Let's find the indicated probability. Let's find the probability of A and B. Well, so we want to find the probability of A and B. So on the bottom, I will either have the probability of A or the probability of B. What they gave me is the probability of A. So what this means, A has already happened. A has already happened. Which of these two says A has already happened? That's right. That one says A has already happened. So I'm going to put that here. The probability of A and B goes on top, and the probability of A is on the bottom. Notice I didn't need that piece of information. I am asking you, do you know which pieces of information to use? So we have probability of B given that A has already happened. These two always need to be the same. If A is second, you need the probability of A on the bottom. So the probability that B will happen given that A has already happened is 0.8. The probability of A and B is what I'm looking for, so I'm going to call it X, and this is 0.1. So let's go ahead and put 0.8 over 1 so I can cross multiply. 1 times X, that's going to give me X. 0.8 times 0.1 gives me 0.08. And because, notice it's an and, so the probability got smaller than the probability of A. So that's how you're going to do 12, 13, 14, and 15. So remember, use this formula every time. And I am going to, because I am questioning you on which ones do you need. I am going to give you more information than you need. Remember, the probability of the event that always happens goes on bottom. Alrighty? So use that formula, answer questions 13 through 15, and then come back for the next video.